So if you wander to the front, maybe take the mic.
I know. I know. Yeah. Today is Tuesday, October 21st. This is the Algebra 2 lesson for 3-4, solving multivariable systems of equations. Yeah! Sounds a little frightening. But before we begin that, we're going to talk about number 8 of the previous homework. Number 8 had 3 inequalities to solve. And when you do the first 2, Ella rightly said that there is a point at -3, -3. Okay. Where were we, Ella? I don't remember. You don't know. Oh, yeah, you were graphing this equation.
I just finished it.
Did you? What were the other 2 points?
I know. Oh, 5 negative.
Right. And
2.
there. See, you totally got it. Okay. So, Jessica, how did all that go for you yesterday?
Oh, sorry, I was.
How did it go for you yesterday?
Yeah, I'm coughing.
I know, I heard that.
Well, see, what happens with that is I got out of school super early yesterday,
Okay.
and I had to go, and
right.
I didn't really get to do number 8 because I don't have a place to keep graph paper and stuff at home.
Uh-oh.
But I did number 4, so for number 8, I'm kind of just.
Okay.
Yeah.
Well, you know what I think might be a good idea is that you and I have another time, set a time to talk about these. Because
Yeah,
I know you're coming in with a little bit lag time because of all this tech stuff, right?
Yeah.
Yeah. So if you don't mind, I think we should start on the next section, and then we'll work on graphing me and you. And Stormy.
Yeah, that's
why
fine.
we're recording this lesson right
Yeah.
now. Okay. Great.
Okay.
All right, everybody, it's on page 138. 138.
That's in the next volume, Anita.
Oh, sorry.
Oh, it's okay. I didn't know that until just now.
No. Like a 3-4. We've already done 3 sections of this chapter. 3-4.
Actually, it's 3-5.
It is?
Oh.
Why did I skip 3-4?
I was on 3-4.
Hold on. Hold on. Yeah, I was going to skip that because it's weird.
So you skip.
Yeah.
You found that 3-4.
I know, because look, you should look at this 5. It doesn't look like a 5 in my book. It looks like a blob. 3-5, 138. Hey, at least the page number was right. Right, guys?
Yes.
Linear programming, I'm not going to bother with that. Oh. Ignore 3-4. I mean 3-5, linear programming. This recording is for 3-5. Starting on page 138. We're talking about systems of equations with 3 variables. Have you ever noticed that all equations with 2 variables are flat? Right? They're curves on a piece of paper, or they're a straight line on a piece of paper, or they're a squiggle on a piece of paper, right? What do you think 3 variables shows you? I know, I screwed it up, didn't I? That's okay. So what does it show you? 3 dimensions. Okay? So, for instance, you got your y and your x and your z. Z is up here. So x and y are on your tabletop, Jessica, and z is if you were to go up in the air. That's z.
Oh.
That's like graphing in 3 dimensions. Yeah, isn't that weird to think about? Like if you were thinking about the corner of a room, all the walls are your 3rd dimension, your z. Anything that goes above, and then the corner is your x and y on the floor. So today is how do we solve systems of equations with 3 variables. So I want everybody to take a gander at the little paragraph above the concept box that says systems in 3 variables in capital letters.
Oh no.
Do you see it, Jessica?
Yeah, I found it.
All right. How about you start reading today?
Me?
Yep.
Okay. Can you guys hear me okay?
Yeah, I'll not hang up this time when I press it. Go ahead.
Okay. The system of equations above has three variables. The graph of an equation in three variables, all to the first power, is a plane. The solution of a system of three equations in three variables can have one solution, infinitely many solutions, or no solution.
So who can give me an example of a plane, a real-life object?
The wall.
Okay. What about something you can pick up? Nope. That's
Paper?
That's a piece of paper. Absolutely. Yeah, but but it's not as tall as a book. You see, you gotta have a little grain of salt, right? Yeah, it's a piece of paper. So I know that in Braille, these pictures are going to be a logistical nightmare. So do you have
Yes.
2 pieces of paper, Jessica, at your disposal that you can?
I could find some. Yeah. My para will find some.
That would be great. Because we're going to look at what it looks like when 2 planes intersect.
Oh. Okay, I have the paper.
Okay. So in print, you don't have to read this, Jessica, because we're going to show it to you with the 2 pieces of paper as best I can do with my words. So you can have one solution, infinitely many, or none, just like with lines. One solution is when the planes intersect at one point. So with your piece of paper, only touch 2 corners of each of the pieces of paper together. Put one corner on the other corner, like where it's just pointing kind of out like a bow. Don't let any other pieces of paper touch, except 2 corners. One corner to another.
Okay.
That's what it looks like when the planes intersect. At one point, because they only touch at that one little itty bitty corner. Does that make sense?
Okay. Yes.
That's what a plane intersecting at one point looks like. They have one solution, and they're just kind of crooked on one another at the corner. You can have infinitely many solutions in 2 different ways. One is when they intersect at a line. So stick your piece of paper perpendicular to it. Do you know what that means? Stick one going straight in front of you, then stick one pointing to the right. So that one edge touches the middle of the other piece of paper.
One edge touches
the middle. So like you can lay it flat too. Lay one piece of paper flat on your table and then hold the other one so that the edge is sitting on it.
Oh, okay.
See? So that edge, that intersects at a line.
And that's the infinitely many?
That's one type of infinitely many.
Oh, one type of infinitely many. Okay.
Yep. So they intersect on a line. It's like standing on, if it could, if there was no gravity, right? You have to hold it for now.
Yeah.
Now, you can also have infinitely many solutions when the planes intersect on the same plane. So imagine if if that piece of paper was cut in half, and you could slide the other one through and make like a plus sign. Does that make sense? So they kind of intersect, they kind of cut each other in half. So it looks like a plus. Yeah. Those are, so we can have them intersect at one point, we can have them intersect at a line, or they can intersect each other. Okay? There's also such a thing as no solution. So in this place, it's just like parallel lines, right? No solution means parallel planes. So you lay one piece of paper on the table, and you just hold the other one flat above it, so that no part of the piece of paper is touching it. So they're parallel to one another. And in the book, they have a couple of different examples of that. Okay. So if you want, you can try and dig through the tactile graphics, but I know from experience that 3-dimensional tactile graphics are not very informative.
No, they're not.
So does that make sense? We have one, many, and none.
Yeah.
Okay. What about you print users? Can you see those pictures okay? They're kind of weird, aren't they, to get your eyes adjusted to them? Yeah. Okay, well, look at the top of the next page. And Josiah's going to read paragraph.
Great, thanks for volunteering.
Oh, yeah.
I did have all
What's that?
I said
You're gonna
thanks
read
for
the next
volunteering.
paragraph
Oh, yeah.
at
True.
the top of the page. Solving. Go.
You okay?
Go ahead.
Solving systems of equation. What?
Keep talking.
Oh, no, my teacher asked who was talking.
Oh, it's it's like, what the heck? Solving systems of equations in 3 variables is similar to solving systems of equations in 2 variables. Use the strategies of substitution and elimination. The solution of a system of equations in 3 variables, x, y, and z, is called an ordered triple and is written as open paren x, comma, y, comma, z, close paren.
Okay. There's a lot of information in that paragraph, isn't there? Who remembers what substitution was? Do you remember that from 2 days ago? It was 2 days ago. Substitution and elimination, where we could add the equations or subtract the equations to find the answer? Well, great, right? Hooray, it works in 3 variables. So you got to match up your x, y, and z this time instead of just 1 or 2. Okay? And doesn't it make sense that if you have x, comma, y, comma, z, it's an ordered triple instead of an ordered pair? Ordered triple means 3, doesn't it? So your answer will be open parens x, comma, y, comma, z coordinate. It'll just, like usual, and you're just going to add the z at the end. So let's take a gander at a set of these in example 1. 1 solution. Oh, good. What does that tell you, guys? The answer is going to be 1 point. Yep. Okay. It says, solve the system of equations. All right. The first one, x plus 2y plus z equals 10. 2x minus y plus 3z equals negative 5. And, of course, 2x minus 3y minus 5z equals 27. Okay, it's a lot. But do you see anything that matches right away? Are there any matching variables we can get rid of right off?
Oh, there's 2x's.
Thank you. Absolutely. There are 2x's. How do we get rid of them? How would we get rid of them in these equations? Subtract them. Right. And so in the book, they decided to multiply everything instead. But yes, you could have done it the long way. They did that so that all of them would have 2x first. Does that make sense?
Yes.
So they multiplied the first equation so it would also have a 2x. Which is really frustrating, but okay. And then they subtracted the top 2. So this book likes to go in numerical order, I guess, right?
Yeah.
So first they multiplied the top equation by 2 and got 2x plus 4y plus 2z equals 20, and they subtracted the top equation from the middle equation. 2x minus 2x, nothing. 4y minus y. Huh?
Subtracted the second.
Oh yeah, right. And 2z minus 3z is negative z equals 25. Okay. And then they do it again, and then they do it to the bottom 2 equations. So they've got one equation over here on the right, but then they do the middle one minus the bottom one. Yeah.
I don't know about that.
Yeah. You can do it. Okay.
No, that just.
Huh?
Explaining that.
I know. Explaining is hard.
Hard to grasp that.
Right. Okay. Let me restart over then. You have 3 sets of equations, and generally the best course of action is to start at the top 2, and then do whatever you need to do to eliminate, in this case, x. And to do that, to make the x's match up, you multiply the top equation by 2, right? And then you get...
Well, there's already 2 equations that
match up, right.
They want to-
Okay, so Josiah, if you really wanted to, since two of them already match up, you could have done the bottom ones first. I'm just following the book now at this point. But yes, you're absolutely right. You totally could have done the bottom one. See, it's right below. It's right there. And they get, when they do it your way, they get 2y plus 8z equals negative 32. So, but notice, as they say in the book, that the x terms each equation have been eliminated. So the result is two equations with the same two variables y and z. So what do you think you're going to do with those? Does that make sense? You're going to take the two answers you got when you subtracted the top two and the middle and bottom one and solve a second system of equations with only two variables the way you're used to doing. I feel the pain.
Like we did before, right?
It's messed up. It's just, the thing is, think about it. You can't find any single variable until you reduce it from 3 to 2 and then 2 to 1. Okay? And remember, whatever you do to one set of equations, you have to do to all the others. That's why we have to do it twice. Does that help?
Do you guys remember last week we were doing a system of equation with two variables? Okay. So what we're doing now, we have three variables. So we have to knock it down until we get a system of equation with only two variables. All right? So we break it down from three variables to two variables. All right? Once we get it down to two variables, we solve for our variables, right? Plug them back into our original equations, and then get our x and our y and our z. Okay, so it's just basically one more step than what we were used to doing before. All right, we just have like one or two more steps. Okay?
Well, you guys learn best by doing. I know that. So, bear with me. Do you have any questions, Jessica? Did you hear?
No, not. It all seems to make sense.
Okay. So I'll repeat one more time. With this system of equations, the original, right? You first figure out how to make the variables match in the top two. In the top two, we have an x, a 2y, a 2x, and a negative y. We're going to ignore z for the time being. Okay. So in order to get the x and the 2x to match, we have to multiply the whole top equation by 2, giving us the new equation, because when you multiply in a whole equation by 2, you have to multiply everything in the whole equation. 2x plus 4y plus 2z equals 20. Okay, that's the first one. And we subtract the middle equation we were given from that, the 2x minus y plus 3z equals negative 5, because that will eliminate the x's. Then we leave our new little equation alone. We leave it alone. You get the answer like they did in the book, 5y minus z equals 25, and just remember that it's there. And then you move on to the second two system of equations of our original, which is the 2x minus y plus 3z equals negative 5, and the bottom one, 2x minus 3y minus 7 equals 27. Hey, lucky us, it's already matched. The x's are already matched, so all we need to do is subtract these two. That's the lower left one in step one, Josiah. And then when they do that, they get 2y plus 8z equals negative 32. So now we have two equations with only two variables. The 5y one in the middle right of step 1, and the 2y one in the bottom left of step 1. So now everybody take a gander at step 2 in your example. After you've done all the subtracting to eliminate into two variables. It says solve the system of two equations. These are the ones we just got by doing all that subtracting. Now this one, we already know how to do because we've done it before. What's the easiest variable to match up? you remember the trick I told you, Jessica, about finding something to multiply to match variables?
Not really. I thought I did, but wait a minute. Isn't that what I just said earlier?
We're on step 2.
Oh yeah. Okay, I see it.
So what will we multiply to make one of them go away? Because one of them has a 1 in front of it, doesn't it?
Yes.
Yeah, you multiply by 8 because it's way easier to match 8 and 1 than it is 5 and 2, is it? Right? So you would multiply the top equation by 8 and get apparently 40y minus 8z equals 200. Okay? That's your top equation. Now subtract it from the bottom one. And you finally get what y is because we eliminated z. So y is 4. Yay! We got one, right? Oh my goodness. Now we got to substitute y in 4 in for y. But okay, here's the trick to remember. Stick it in the 2 one, the one that only has y and z in it. Otherwise you're going to have an x and that wouldn't make any sense. So when you get a value, substitute that in for the system of equations you got that for. In this case, 5y minus z equals 25. Does that make sense? Don't put it back in the original or you'll have an extra variable on your hands. So when you put 4 in for y, you get 20 minus z equals 25. So you minus 20 from both sides. And you get negative z equals 5 and z equals negative 5. Alright. Now that we actually have a value for y and z, now you go up to the top and put it in your original.
It's single column.
It is. It's a whole page. It's a whole page in the book too, right? So you have y equals 4 and z equals negative 5. That means the only one we don't know is x. So to figure out what x is, you plug in 4 and negative 5 into one of the original equations at the very top of the page. It doesn't, so you can pick the easiest one for yourself. The book liked x plus 2y plus z equals 10. They picked that one. So x plus 2 times 4 plus negative 5 equals 10. Apparently x is 7. So now you've got all the points. And given that information, when you have all the points, make sure you put them in order in your triple, x, y, z. So it goes 7, 4, negative 5. Okay. This is why we take notes, right, folks?
Yep.
First, you take the first set of equations and turn them into a set of 2 variables. Then you solve that 2 variable equation for a y or an x or a z value. Once you get that value, plug it into the set of 2 equations and get your second variable. Once you get your second variable, plug it in to your original, one of your original with a 3 in it, 3 variables in it, and get your third variable. Yep. We're going to practice it again. Turn the page. This one is going to have infinitely many solutions. Yep.
Ow.
Ow.
Oh, I've got a paper cut.
Oh, wow. One of my students got one earlier. All right. Here we go. Same set of steps. We're going to apparently get something with infinitely many solutions. Solve the system of equations. Okay, top 2 first. Okay, how do we make a variable go away in the top 2? We have a 4x, a 6y, and a 4z, and a 6x, a 9y, and a 6z. You generally pick the one that's easiest to make. Yeah, not 4. They picked a different one. I might have you guys just practice this today. Just solving these things. We might do only half this section today. Because I think you need some extra practice. How do we get X and Y to match up? Or X's to match up? Anybody have any ideas? Here's how I like to think about it. Find a common, don't say denominator, right? But find a way to make them the same number. How do we make the X's same number? Well, we have to multiply each equation by.
Multiply by 3.
Yeah, you pretty much have to you pretty much have to multiply in such a way that you get, like you find a common denominator. What is a good number that they both have in common? 6 and 4 have in common. 12!
2.
We want to turn the X's into 12. So what do we have to do with the top equation to turn the X's into 12?
Multiply by 3.
Yeah. How do we get the bottom middle equation to turn into 12?
Multiply by 2.
Well, the book chose -2 because then you
Why?
can add the equations together. But that's a personal choice. Okay? So if you multiply by 2, you would subtract them because you would have a 12 and a 12. If you multiplied by -2, you'd have a 12 and a -12, and you could just add them. So let's pretend we multiplied by -2 so that we can keep following the book. Okay. Once you do that, they get this huge thing, don't they? Just follow along, okay? Because otherwise it would take forever to do them. And we're only going to do these 2 examples today, and we're going to practice them in the book after this, okay? And tomorrow we'll work on the second half of this section. So when they multiply the top equation by 6, when they multiply the top equation by 3, they got 12x minus 18y plus 12z equals 36. And when they multiply the bottom equation by -2, excuse me, hiccups are awful. Negative 12x plus 18y minus 12z equals -36. Okay, so we have a 12x and a -12x, so we have to add the equations together. And look at that, you have a -18y and a positive 18y. Uh-oh, that goes away too. You also have a 12z and a -12z. 0 equals 0. Remember what that meant?
No solution.
Yeah. Well, the equation 0 equals 0 is always true, right? 0 equals 0? Can you ever?
Yeah.
Yeah. So, this indicates that the first 2 equations represent the same plane, just like they did in when we were doing lines. And then, of course, you have to check to see if the planes intersect intersect the third plane. So what they're saying is we need to check the bottom 2 equations. Okay. So, excuse me. What they want to know is if the first one and last one are the same. Okay. My brain hurts too, guys. Don't worry. Well, we know that the first 2 planes are the same plane. What we don't know, so the thing is, if they're the same plane, does it matter which equation you pick when you compare it to the bottom one?
No.
No. So the book just took the top one. Does that make sense? That's why they did that. It doesn't matter which one, and they chose to do 4 instead of 6x. Okay. How do we make these x's match up? How do we make a 4x and a 5x match up? Oh, no. Sorry. They want to make the z's match up. Never mind. How do we make the z's match up? We've got a 4z and a 10z.
4z and a 10z.
What's their least common multiple? That's the right word.
The least common multiple.
20. How do we make 4z into 20?
Multiply by 5.
Yeah. And how do we make 10z into 20?
Multiply by 2.
Exactly. So you multiply the top equation by 5 to make it 20z. and you multiply the bottom equation by 2 to make, well, again, they use -2 because they like adding. They multiply the bottom equation by -2, because that will make it a -10. Okay.
Yeah.
Well, when they do that, they get, they get 10x minus 14y equals 20, but they realize that 10, 14, and 20 can be reduced, can it? What does 10, 14, and 20 have in common? Yeah, they're all even. They're divisible by 2. So they just reduced this entire equation to 5x minus 7y equals 10, because they divided 2 out. They all had a common factor of 2.
Oh.
So the plane intersects on the same line. So there are infinitely many solutions. So what this is saying is that these planes intersect at the line 5x minus 7y equals 10. Because remember, the first two were the same plane, and when they solved the second set of equations, they intersected at a line. We got a line.
Mm-hmm.
We didn't get a anything equals blah blah, right? We didn't get a y equals 4 or z equals 7. We just got they have the same line.
Yeah.
Okay. I'm not gonna move on yet. Okay.
I'm still writing it down.
Okay. Let me. Number 1. 1. 4. Okay. Problems are going to be 1, 4, 5, and 6 today. I'll repeat for Stormy's benefit. We're on page 142. Your problems are going to be 1, 4, 5, and 6. And at this point, I will stop the recording. And tomorrow we will move on to the second half of this section. Because I really want you folks to get this down solid. Once I figure out how to stop the recording. And we can go to the first one together.
Did you say 145?
142.
No?
42.
142. Okay, where did I get 45 from?
I said that. Would you guys like to go through the first one together? And not number 1. You're going to do that one on your own because I want you to explain that to me. But number 4.
Okay, so 4.
I didn't hear anything. I'm going to assume you mean no.
I said yes.
I heard 1 yes. I haven't heard anything from silent peers over here. What do you think, Ella?
Silence.
No? 1 no, 1 yes. So I get Josiah as a mumbler. I'll pass. Okay. Well, Jessica.
Yay.
Okay. Stopping recording. And Stormy. I'll do it for Stormy, too. So we'll ignore the other two. They think they're so awesome. All right. Look at number 4. Take a gander at number 4 on page 142.
Mm-hmm.
And tell me what it says, Jessica, when you're there.
Okay, it says, oh, that's weird. It says x plus 2y equals 12 for the first equation, and then it says 3y minus 4z equals 25, and then it says x plus 6y plus z equals 20.
Great. All right. What variable do you want to match up? Because remember, the first thing you do is look at the top 2.
Yeah. Okay. So then
whiteboard. I need to do this on a whiteboard with on this track. You have a brailer, I hope. You're going to lose track of this stuff.
Yeah, I have something I can write on. Okay. The first equation doesn't have, or the second equation doesn't have an x variable.
Right. So you want to try and match up the x's?
Can we match up the x's if there's no x?
Well, yeah, it does. It's 1x, right? When x is just on its own, it's a 1x.
Oh, I mean, yeah, but the second equation is just 3y minus 4z.
Oh, right. There's a 0. Oh.
Yeah.
0x plus y minus 4z equals 25.
Oh, okay.
Right. Well, anything times 0 is always 0. So how about we try and match up the variables?
The y variable?
Sure.
Okay.
So what are our two coefficients of y?
3 and 2.
Right. What's their least common multiple?
6.
Right. So what do we multiply the first one by to get 6?
3.
Okay. Go ahead. 3x.
Okay. 3. Plus 6y.
I would if you would actually tell me you needed time.
Huh?
You never tell me. You guys realize the reason I go on is because you don't stop me. Okay? You are high school students. You must advocate for oneself.
I was reading it.
I know. But if you're stuck at the top of the page, you have to stop me. Because if you don't say anything, I don't know. Hello? Okay? Does that make sense? Okay. So don't mutter about it when you think I'm not listening.
No, I know.
Get to work. All right. What's your Jessica?
My equation that I got was 3x plus 6y equals 36.
Beautiful. Now, what do we do to the bottom, or the middle one? What do
We multiply that one by 2.
That is correct. So 0x.
Okay.
Put that in there. 0x.
Okay, 0x. And that's a plus.
Yep.
Yeah.
Yep.
3, or no, not 3. That'd be 6y
There you go.
minus
No.
8z.
Oh,
No?
yeah.
Oh, yeah.
Oh,
Multiply
we
by
forgot 0
3.
at the top. Right?
What?
We forgot 0z at the top.
Oh. Yeah, I'll go put that in.
0. I'm squishing it in. There we go.
Plus 0z. Oops.
Yeah. But we're gonna get a y
Okay.
there, thankfully. Okay.
Yeah.
Equal.
Okay, so that'd be 0x plus 6. Wait, are we on the first one now again? The first equation?
No, it's just after 6y, you were supposed to put 0z since we didn't have any z's.
Okay, I did that
Okay.
after you
So
said it. Just
Then,
now.
yeah,
Okay.
fix it. 0x,
0x
6y,
6y minus
minus 4z,
multiplied by 2, 4 minus,
Times-
that'd be 8z, wouldn't it?
times 2, yeah.
Minus 8z, and that equals 25 times 2 is 50.
50! Yay! Okay.
There we go.
Now what do we have to do to get rid of these y's with these two equations?
I don't know.
There you
Wait
go.
a minute. Both of our y's are 6.
Right, so how do we get rid of a plus 6 and a plus 6?
6 minus 6?
Yeah, so we subtract the two equations, don't we?
Yes. Oh, we subtract.
Yep, start from the left. 3x minus 0x,
That's 3x.
right? 6y minus 6y is nothing.
So 3x, and then there's nothing. And then
0z,
0z minus 8z.
right?
0z minus 8z would be negative 8z.
That's correct.
Okay. And
Equals?
then the Can you 36 minus 50?
Yep. What's that?
That's negative 14.
There we go. Whew, we got one. We got one equation of two variables. Oh yeah, go us, right?
Yay. Yeah.
Okay. Down off to the side.
What?
You're gonna have to keep that somewhere because now we have to find the second equation.
The second equation.
3x minus ac equals minus 14. I'm using two whiteboards for this. Okay.
Wow.
Ah, where's my eraser? Aw, there it is.
Oh,
Okay. Now we need another set of equations with x and z. So how do we eliminate y from the middle and bottom equation?
from middle and bottom equation. Let me see. Well, we have a 3y and a 6y.
Great. So
Here.
what can we do there? And we can't forget the zero this time.
Oh, yeah. Can we find the common multiple for these ones
Sure.
too, or no?
Well, because the equation we got a second ago, ask permission. Okay. Three. So because Jessica, our last equation, we had 3x and 8z. We need to eliminate y from the bottom two. So how do we eliminate the 3y? How do we make them have a common coefficient? Yes, you're supposed to do that. I want you to really explain it. I'm talking to him.
Can I explain it?
Okay.
On your paper. So what do we multiply by to make them match up, Jessica?
We would have to make them. Okay, so hang on. So can we find the common multiple again, or for these last two?
Well, this
No.
yeah,
Okay.
but it's pretty.
Yeah.
It's the same thing. You just start over with the two equations. So.
Oh, okay.
What would you pick between the two of them?
Probably 12.
That'd make your life hard on yourself. Can we do something to the middle equation to make it match the bottom one?
Make it match.
It's easy when one of the coefficients is a factor of the other.
Oh. One of the coefficients. Because 3 is a factor of 6.
Right. So just make the 3y into a 6y. Right?
Okay.
Yeah, you don't have to do both this time. That's nice. Only multiply by 1, or multiply one of them. So let's get to it. What do we multiply that middle equation by to make it match the bottom one?
We multiply by 2.
Correct. 0x times 2.
That's 0x.
Right. Plus.
0x plus 6y.
Very good.
Minus 8z equals 50.
Again. Yep. That's kind of funny. It's the same one.
Yeah, that's like the exact same equation.
Minus.
Okay. And then we subtract that by 1x plus 6y plus 1z equals 20.
That's right.
So I'm going to write that real quick.
That would be good.
X plus y
What are you writing on?
plus z. Well, see, what I'm using is, since I don't have, since it makes things easier for me, I'm going to try it on the Braille note, and I actually am doing pretty good so far, because you can just make lines between them, and it all works.
Okay. I was just curious since I didn't hear any Braille sounds. All right, let's do it.
Oh, well, my computer's quiet. Okay, so x plus 6y. I wish I was writing on paper. Equals 20. I mean, like the paper. Makes things easier. Okay, got it. So now I just need to minus it.
Right.
So 0x minus, oh, hang on, make things a little more, okay. Equals, okay. So 0x minus 1x, that's negative 1x.
Right.
So that's just negative x.
Yep.
But if I put the 1 in front of it.
Yeah, if it helps you remember, that's fine.
Okay. And then that's plus 6
Nothing.
minus 6. So that's nothing.
Right. That was the whole point we did this, right? To get rid of the y's.
Yeah. Okay. And then the 8 minus 1z, that's 7z.
Nope, careful.
Oh,
It wasn't a positive 8, was it?
Oh, yeah, that's right.
Really careful. Check your sign, too. So what's negative
Okay.
z minus z?
So, okay, that would be a plus, wouldn't it?
No. Because we're not multiplying. We're only subtracting. So if you owed me $9 and I let you borrow another $1, or I'm sorry, if I owed you $8 and you let me borrow another $1, how much would I owe you?
That'd be negative 9.
Right.
Yeah, it's negative 9z
Right.
plus negative 9z, and that equals 50 minus 20, so that's 30.
Huh? 50 minus 20. Oh, yes. I had I thought it was negative 50, so I had negative 70. So you're right. Oopsies. Hold on. 30. 30. Okay. 30. Okay. Okay. Now put this newy one next to the one we did earlier.
Okay. Let me.
15.
Oh, cool. I can copy.
So I wrote it over here. What was it again? Negative x minus 9z. 30.
Are you alright?
No. Equals 30. Okay. Now we've got a set of 2, finally. Don't we?
Yeah. So negative x minus 9z.
Whew.
That's 30. And then.
So if I were you, I'd put the 2 equations next to each other in your braille notes so you know what they are.
Yeah, I have to find the first one we did was 3x minus 8z equals negative 14.
That's right.
Oops. 3x minus 8z equals negative 14. Okay, got them.
Okay. Now we solve these ones. Yep.
Awesome.
So what variable do you want to eliminate?
Can we get rid of x?
Yeah, I would. Which
Okay.
one do we have to change? How do we make 3x and negative x almost the same?
We could multiply negative 1 by 3.
Beautiful. I think that's a great idea. So yes, that means we multiply the bottom equation by 3.
The bottom equation.
Yep.
Yeah, that's right.
That would make 3 and negative 3. That's fine, because then we can add, right?
Yes.
Okay. So let's multiply the bottom equation. Minus 3x.
Right.
2 minus 27z equals 90. Gross.
Oops.
Variables.
Oh, yeah. Okay.
Right?
Okay, so.
Yes.
All right.
That's right.
Now, how do we get rid of a 3x and a negative 3x? What do we have to do to the both equations?
Okay, and eliminate the y, the second and the third equation.
You can add them.
Add them.
Okay?
Right. Very nice.
Yes.
Okay. What's 3x plus negative 3x? Ah.
I still have time if you do.
I do. Let's finish this up. I'll get you to at least where we find z. Right? And then
Yeah, at least where we do that.
All right.
Okay.
0x, right? Nothing.
Yeah.
Minus 8z plus a negative 27z. Ew.
Lovely.
What is that?
Oh. 8z plus negative. Wait a second.
Now be careful. Look at your signs.
Okay. Negative 8z plus negative 27z.
Right.
So, negative 8 plus negative 27, that's negative 35.
Right. Negative 35z equals?
Equals,
Oh.
We must do.
going on over there.
Oh, we're changing class to 8, so other students are coming in.
Oh, okay.
That's all.
If we're adding, we have to do 30 plus
Now what?
negative 14.
Not 30. Remember, we multiplied
Oh.
by 3. What did 30 become?
Oh, 90. Yeah,
There we
I read
go.
it wrong.
There we go.
90 plus negative 14. That's 76.
Yeah. That's not right.
No, that doesn't look right at all, actually.
Okay. Well, we're going to work on this tomorrow, so it's all good.
Okay. Yeah.
And I encourage you to try it over again tonight, okay?
I will.
Just try
Yeah.
that problem.
Yeah, I
And
will.
see if we can figure out where you and I went wrong. Okay?
Okay.
All right. I will talk to you tomorrow and we'll continue this.
Yes, ma'am?
Okay.
Bye.
What? Oh, this
Bye.